Here is an exam question on the topic of vectors. This is probably most students' nightmare. This particular example is rather challenging. Hopefully this question will give you a better understanding of the topic. But don't worry, you're not alone if you're struggling with it. Most students are struggling with this topic. So here is a parallelogram. OA is vector A, OC is vector C. X is the midpoint of the line AC. So these have been labelled, but AC is not drawn, X is not drawn. OCD is a straight line, so that OC to CD is K to 1. So point D is also not on the diagram. We'll draw that in a minute. Given that XD is equal to 3C minus half A, find the value of K. Right, so not much information is given. So let's go ahead and write as much we know onto the diagram. We might need to use those vectors, so just put them on. Now, AC, so let's draw that line, somewhat like that. So X is there, and point D is somewhere on this line. We're not sure where it would be, so just for illustration purposes, I'm just going to put that here. Excuse me. So here is K to 1. So that's K parts. This is one part. Now I've also been given X to D, which is, let's put that 1 over here. X to D is right. So I've been given XD directly, so I can, if I go from X to D like that, that would be 3C minus half A. That's given. So we need to find the value of K. To be able to do that, if I can go from X to D via C, so going from X to C and then C to D, I may be able to find the value of K if I can involve K somehow as well. So to find XC, we know that X is halfway of AC, so let's find AC. So to go from A to C, we're going down this way and then C. So that's minus A plus C, or C minus A. Therefore, XC is half of that in the same direction. Now, to go from X to D, as I mentioned, to go via C, we have to add XC and CD together. So XD is equal to XC plus CD. I already have XC, but I don't have CD, so that's the tricky part really. So CD is equal to one part. We know that it's going to be in the direction of vector C because it's on the same line, but what magnitude, that's the tricky part. So one part out of K, hopefully you notice it's going to be 1 out of K parts in the same direction of vector C. So for example, if this was 2, then you do 1 out of, so it'd be 1 out of 2. If the ratio was 2 to 1, for example, then you do vector CD would be half of vector C. So if K was 3, then you would do 1/3 of vector C. Right. So CD is now found. We need to add these two vectors together. So XD, it's going to be a half C minus A plus 1 over KC. Now, I know that this vector, so XD, we just found it via a different route, and we also had it in the question that it was equal to 3C minus half A. So if I can now make them equal to each other. Let's go over here. So 3C minus half A equal to half C minus A plus 1 over KC. Now, if I expand the brackets and tidy things up here, I can compare coefficients. So that's half c plus half c plus 1 over k c. So that's half plus 1 over k lots of c, and then minus, so that times that, minus a half a. So I can see here that vector a has got the same coefficients on both sides, which it should. So it's now we can make, so 3 must be equal to the coefficient of c on the right hand side. So coming over here, 3 equal to 1 over 2 plus 1 over k. So take away a half from both sides. It's going to be 5 over 2 equal to 1 over k. Therefore, k must be the reciprocal of that.